welcome everyone to Learn a Trade. My name is Kevin Tate, and today we're going to get into a Turbo Chef upper heater replacement. For me, usually I do these repairs in the shop. I usually will remove the machine from the site and then do the repair in the shop because there's just not enough room in some of these locations sometimes, so this way I'll have enough space to get around to everything. I'm basically going to be taking this unit apart, removing the transformers up top, and then removing the upper panel to access the upper heater, and then remove the old heater and show you a few still clips and a few videos. As you can see here, this is the upper platform of the oven. This is where the upper heater is located. And what I will be doing is I will be removing the two high volt transformers because they're the heavier components. So I usually remove those two transformers, and then I will go ahead and lift the platform up, and then I will allow that platform to rest on a slotted screwdriver or something to hold it up so that I don't have to remove the complete wiring harness. That wiring harness is attached and goes across that platform, so you'll see in the rest of the still pictures on how I usually do it. And you can use anything else to hold the platform up, but you'll have to have it resting on something so that you can have access to the screws to remove the upper heating element, which I will show you in a few still shots in a moment. But as you can see, I do have the touch screen is removed. The faceplate, touchscreen assembly, that whole assembly is removed, and the control board is removed. And I usually set that aside and let it sit to the side somewhere where it won't get hit or damaged. So now here we go. I have the platform lifted out, and later on I'll kind of bring it down just a little bit and balance it on a slotted screwdriver just to give me enough space to get inside and get all of the screws out of the heater element. Right here, this is the actual upper heater, and you can see the terminals on the left and the right side, and the screws. There's about 6 to 8 screws in that element platform there that will be removed. And here is one of the reasons why it was shorting out. This wire is frayed down to the bare wire, so it was touching against the platform during the heat cycles. And right here I have the platform resting on that the bottom of the handle of that slotted screwdriver, just to give me enough room to get the screws out. And this is the replacement upper heater. You can see that part number there, NGC 3011, NGC-3011. And right here I have the old heating element out, and this is the bracket that it sits in, this mesh bracket. That new heating element will sit right in there, and there is directionals on there. I don't know if you can see it, but on the bottom it says front, and on the top it'll say back, and you'll want to put it in that way. This is the old heating element that I took out, and over on the left you can see one of the terminals, the ceramic insulator is cracked on one side. This side right here that you're seeing now is good. This little ceramic insulator, that's the way it should look. But you're going to see the one on the other side where it's split right here. See that split right in there in the ceramic, and then the piece of the element is kind of bent out, and when that's inside that little mesh caged area, that touches against the metal, and then it ends up causing it to short out or arc against the mesh bracket. So that's another of the issues there. This is the new heating element right here, and I will be putting that in place. It comes with the insulation seal around it, the heated insulation seal. And now this is the new heating element in place. And you can see, like, around the area, you can see the soot that built up because the exhaust was totally clogged. So when that exhaust tube is clogged, it's gonna cause a lot of soot and a lot of steam build up in that upper area. And now I have all of the screws are in place. The new upper heating element is in place now and secure. You can see a lot of the tape has a lot of stuff all over it. And now this is a little video of the new upper heating element in place. This is one of the terminals. I'm just tracing it for you to show you where it goes. That heater terminal, that goes to that far side terminal on the EMI filter. That's your EMI filter. That's where your power comes in at. And that the other heating element terminal connects right down here on the high limit switch, and it connects to terminal number 22. And I'm just tracing it back up to show you this is the new wire. I had to run a whole new wire because that other wire was frayed. And then I got that wire connected, and then I just retaped everything. That way you can see that at least that portion of the wire is covered with some of the aluminum tape. And then I have both of the terminals are connected, and there's a little orange insulator on the top that I put there just to make sure that nothing touches the top of that terminal. And right now I'm just checking to make sure my wires are secured good. They're not moving around. You don't want them loose in that area. And then there's covering. There's a covering that goes over that hole, that opening for the terminal. So I retaped that. I put new tape on there, and that's all secured now. And now I have my two high volt transformers are back in place, secured and wired correctly. I have my new my magnetrons are back in place on both sides. I placed the air vents back in place on both sides. That's the ventilation for the magnetrons. The magnetron fans blow through that. And then I have my faceplate back on. The control panel and the faceplate display is back in place and secured. just going back over all of the wiring to make sure I didn't miss any wires, because to do this you have to take just about all of the wires off of the terminals up top. So you just want to go back over all of the wiring, make sure your wiring to your main board is correct. Make sure they're back on completely. Right now I'm putting the machine back into operation and getting set to do a few test cook cycles just to see if I come into any error codes or anything. So what I use for that, some of you probably seen it before on some of the other videos, I use a wet rag and I put it into the cook cavity. And in case you weren't aware of that, by putting that wet rag into the cook cavity on the cooking pan, it allows the oven to cook as though it has a load in it, as though it has actual food in it. So that's a good way to test your oven to see if you're getting any errors, and to troubleshoot a little bit and stuff like that. Or even after you make repairs, you can see by doing that before you have the customer cook food and it go into an error code during that cook cycle. It's better to have it where it's just the wet rag in there, and then you can see for yourself if it goes into an error code or anything like that. Right now this one is cooking fairly nice, and it's looking like it's good to go. I'm just letting it go through its cycle and checking the amp draw while it's cooking. There you can see I got like 17.5 around there, so that's a good amp draw. This is only working off of 208 volts input, so the amperage will be a little bit higher. If I was working off of a 240 line, then I probably would get close to 15 to 16 amps as far as the amp draw goes. Right here I'm going back into the menu with the code being 9428, and I'm going to check my fault log again, because after a cook cycle I want to see, did it go into a did it bring up any error codes or anything. And right here I'm just clearing out the error code and then going back out, and then I'm going to go ahead and let it heat back up and then attempt another cook cycle. Again, I'm doing another cook cycle. Looks like I'm getting, right now it's reading 15.5, but I think I caught that on hold. That's my fault. As you can see on that meter, the H is up, is highlighted, so that means I pressed it too long, so it's holding at that point right there. So that's not the actual amp draw. I caught it when it was going up in amperage, so, and I pressed the hold button by mistake. So it's just holding at 15.5, but really it's around 17.5. Usually you'll get 15.5 to 16 amps on the amp draw when you're using when you have like 240 volts going in, but this only has 208 going in, so my amp draw is going to be a little higher. And right now I got this unit cooling down. It looks like it's good. I hope this was helpful to you all. Please let me know in comments, and I thank you all for watching. Take care and stay blessed.